Hey everybody, thanks for clicking on this video. Today we're going to be looking at zeros of polynomial graphs. If you want to follow along, the links to the companion worksheet are in the description below. Also, don't forget to click that subscribe button to stay up to date on all the videos we have coming out from the channel. So let's get started. So what are zeros? Well, zeros are values that make a polynomial zero. Now we're looking specifically at graphs, which means what we're looking for is where the graph intersects the x-axis. So looking at this graph, we have this location right here. So we report that as x equals -4 because we give the x value of that location. Over here, it also intersects the x-axis, so we report that as x equals 0. Over here, that location is at x equals 2. And then over here, we have x equals 3. So these are the four locations where the graph intersects the x-axis at -4, at 0, 2, and 3. Now for number 2, we're asking the same question. Where does this graph intersect the x-axis? Now when people hear about finding zeros of a graph, they often think that it has to cross. Actually, it doesn't. So right here, it doesn't actually cross the x-axis, but it does touch there at x equals 0. And here, it flattens out, but it does cross the x-axis at x equals 3. So those are the two numbers, the two zeros of this polynomial. Now for number 3, now we're going to turn this around and say we want to draw a polynomial graph whose zeros are 4, 5, and -1. So I'm going to draw my x and y axes, and all I'm going to do is I'm just going to label the x-axis, because where the y values are right now don't really matter. So we have zeros of 4, so it's going to intersect right there, 5, intersect right there, and -1. It's going to intersect right there. So one possible way of drawing this graph could be like that. But that's not the only way we could draw it. There's a whole multiple set of ways we could do this. So another way would be something like this. I could come up, I could touch but not cross, touch but not cross, and go up like that. And so whether you cross the x-axis or whether you touch the x-axis and then go back the other way, these count as graphs that fit this description. And so if you want to try others, you're more than welcome to, because this characterization is kind of vague. Now the next one is a little bit more specific, because it says it gives a leading coefficient of -3. Now in the last video, I'm going to post a link to that, we talked about how when you have a leading coefficient that's negative, that means that our graph is going to end up going down this way. So we know that. We know that our graph has to end up going down. So where is this graph going to touch the x-axis? At -2, at 0, and at 1. So one way we could draw this graph is like this. It crosses, and it goes down like that. That's one possibility. Another possibility will be like this. It actually touches, but it doesn't cross. It stays beneath the y-axis, the x-axis, the entire time. So in this graph, as long as the ends are pointed down, that gives us a polynomial with these zeros with a leading coefficient that's -3. Thanks for watching. If you liked the video, please give it a thumbs up. Do you have suggestions or problems you want to see worked out? Type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.